Let's move to the next question here. If 1 plus x square raised to the power n is equal to summation r ranging from 0 to n, 0 to 2n, ar into x power r, then a1 minus 2a2 plus 3 into a3 minus 4 into a4 so on minus 2n into a2n is equal to what? Now, we are given 1 plus x square raised to the power n is equal to sigma ar x power r ranging from 0 to 2n. Now let's have an observation of this left hand side here. Now this is a second degree polynomial raised to the power n, so the output will be a 2nth degree polynomial. Now what have we written here on the right hand side? This is again ascending powers of x written from x power 0 to x power 2n. So the right hand side is also a 2nth degree polynomial. Now these two are identically same. So what we require here is, a1 minus 2 into a2 plus 3 into a3 minus 4 into a4 so on minus 2n into a2n. This is what we require. So it appears that if you look at this expansion here, it is a0 plus a1x plus a2x square so on and so forth, a2n to a2n x power 2n, a2n x power 2n. Now observe that this, it is 2 into a2, 1 into a1 that is being asked here, but with an alternating sign pattern. So what we do is, we first differentiate both sides of this expression. So differentiating with respect to x. Next. So what do we get here? On the LHS we get n into 1 plus x square raised to the power n minus 1 into, now the derivative of 1 plus x square, that is equal to 1 plus 2x. Okay. Now coming to the right hand side. What's the derivative of a0? 0. Constant term derivative 0. So a1 plus 2 into a2 into x plus 3 into a3 into x square. This is what you're going to get. Finally 2n into a2n into x power 2n minus 1. This is what we'll be having here. Now what you wanted was only the coefficients, so that has to be free, it has to be made free from x term here. So how can we do that? If I put x equal to 1, I will be getting a1 plus 2a2 plus 3a3, all the terms with the plus sign. Now how do you get an alternating sign pattern on the right hand side? By putting x equal to minus 1, we can get the alternating pattern here. So what we do is, we will put x equal to minus 1 on both sides. So when I put x equal to minus 1, what does the left hand side become? N into 1 minus 1 plus minus 1 square raised to the power n minus 1 into 1 plus 2 into minus 1, and that right hand side comes out to be a1 minus 2 into a2 plus 3 into a3. So that is even suffix terms will have a negative coefficient and odd suffix terms will have positive coefficients. So we will have finally minus 2n, that is it's ending with the last term, so minus 2n into a2n, that's what I will be getting here. Okay, so this is a2n term here, a2n. So now what do we have this to be? Almost what we wanted is coming on the right hand side, is appearing on the right hand side. So what is this coming? 1 and 1 cancels, minus 1 square, that is 1, n in 1 power n minus 1, 1 only. So n into 1 plus 2 into minus 1, that's minus 1 there. So minus n. This comes out to be minus n. So a1 minus 2 into a2 plus 3 into a3 minus 4 into a4, so on and so forth. Finally, minus 2n into a2n comes out to be minus n. This is what we have here. So what we observe here is, now when you wanted r into ar type of term in the sum of the problem, what you had to do was this r has to come this side here. That means we have to differentiate with respect to x once. So but there is an alternating sign pattern. So what you need to do is you put x equal to minus 1 to get that alternating sign pattern there. So clearly the answer is 4. Well, let's move on to the next question. 2 square into nc naught by 1 into 2, 2 cube into nc1 by 2 into 3, 2 power 4 into nc2 by 3 into 4, so on and so forth, up to 2 power n plus 2 into ncn by n plus 1 into n plus 2 is equal to 3 power of n plus 2 minus 2n minus 5 by n plus 1 into n plus 2. Second option, 3 power of n plus 1 minus 2n minus 3 by n plus 1. Third option, 2 power of n plus 1 by n plus 1. Fourth option, 2 power of n plus 1 by n minus 1. Now, let's see the pattern here. It is 2 square into c naught. We are abbreviating CR as NCR. CR stands for NCR. So 2 square into NC naught. So 2 square C naught by 1 into 2. That's what is the first term. Second term is 2 cube C1 by 2 into 3. So on and so forth. What is the nth term here? 2 power n plus 2 into Cn. That is n plus 1th term because you are starting from 0 here. So Cn by n into. So when you had it, it is n plus 1 into n plus 2. Now can we write this in a form like this? We'll write it in a summation form. That is sigma 2 power r plus 2 into CR by r plus 1 into r plus 2. R ranging from 0 to n. Now, here observe that. Now, putting that in the summation form here, we can write this in the form of sigma r ranging from 0 to n 2 power of r plus 2 into CR by r plus 1 into r plus 2. R plus 1 into r plus 2. Now, let's have a look at this. Consider the expansion 1 plus x power n. What is that? Summation CR x power r. R ranging from 0 to n. Okay. Now, you integrate this within the limits 0 to x once. Integrate this within the limit 0 to x. So, what do we have? This comes out to be 1 plus x raised to the power n plus 1 by n plus 1 minus 1 by n plus 1. And coming to this, integral of sum of functions is sum of the integrals, so we can take it inside, summation out. So sigma r ranging from 0 to n. Okay, integral of this. What is that integral of CR into x power r? We can write this as CR into x power r plus 1 by r plus 1. Again, we are taking within the limit 0 to x. What happens here, when you apply the upper limit, we will get CR into x power r plus 1 by r plus 1, whereas the lower limit, because all the terms will carry a 0 here, so you will have the lower limit to be 0. So I can simply write this as sigma CR x power r plus 1 by r plus 1. Now what you have on the LHS is 1 plus x power n plus 1 by n plus 1 minus 1 by n plus 1. Now is it matching? Suppose if I put x equal to 2, I am getting 2 power r plus 1 by r plus 1, but you have there 2 power r plus 2 by r plus 1 into r plus 2. So it appears that it needs one more integration. So we need to integrate once more both sides within the limit 0 to x. Okay, let's integrate both sides again within the limit 0 to x. So let's integrate 0 to x dx, 0 to x dx. So what do you get out of this here? What do we get here? When you integrate this part, it comes out to be 1 plus x power n plus 2 by, this n plus 1 is already there, therefore n plus 1 into n plus 2. Now when you integrate this part, you get x by n plus 1. But this has to be applied over the limits 0 to x. Okay. So what happens here? And what do you have on the right hand side? This turns out to be CR, sigma CR, x power r plus 2 by r plus 1 into r plus 2. R plus 2. R ranging from 0 to n. Now in order to get this summation, if I put r equal to, if I put x equal to 2, this summation will match with the right hand side. See here, c naught into 2 power, c naught into 2 power 2 by 1 into 2, c1 into 2 power 3 by 2 into 3. So all that will come on the right hand side. So this left hand side should be the value of what you wanted here. So let us see what happens here. We will we'll erase this part here. We'll erase this part and see. Look at this here. Now I put x equal to 2. Put x equal to 2 now both sides. Putting x equal to 2. What do you get? So I replace this by 2 here. So we can just replace this by 2. Okay, so after applying this, we'll put x equal to 2. So what do we have? 1 plus x power n plus 2 by n plus 1 into n plus 2 minus x by n plus 1. Okay, that's the upper limit. When I go for the lower limit, I put x equal to 0. When I put x equal to 0, what do I get? 1 by 1 power n plus 1 by n plus 1 into n plus 2. Okay, minus of, that will anyway be 0, so we'll just leave it 0 there. Okay, so this is what we have here on the LHS. The right hand side will match with the left hand side of what we wanted here by putting x equal to 2. So let's go for putting x equal to 2 here. So what do we get here? We get, put x equal to 2 here. We will get here 3 power of n plus 2 by n plus 1 into n plus 2 minus 2 by n plus 1 minus 1 by n plus 1 into n plus 2. That is what you have on the left hand side. Now clubbing them, taking the LCM as n plus 1 into n plus 2. What do we have? N plus 1 into n plus 2 taken as the LCM. We have here 3 power of n plus 2. No change in the first part. What's the missing term here? N plus 2 is missing. So 2 into n plus 2 minus 1 by n plus 1 into n plus 2. So what does that come out to be? After simplification, this turns out to be 3 power of n plus 2 minus 2n minus 4 minus 5. That makes it 2n minus 5 by n plus 1 into n plus 2. So clearly, as you observe, the right option is answer 1. Okay, answer 1. So in this problem, we had to integrate 1 plus x power n within the limit 0 to x twice and then put x equal to 2. So where did you get that idea? Because this, you see, this is 2 power r plus 2 by r plus 1 into r plus 2. When you integrate x power r once, you will get x power r plus 1 by r plus 1. Once more, if you integrate, you will get x power r plus 2 by r plus 1 into r plus 2. So from there, we got an idea that we had to integrate twice. Let's move on to the next question. The coefficient of x power 4 in the expansion of 1 by x plus 1 into x plus 2 is 1 by 32, 11 by 32, 21 by 32, 31 by 32. Now, let us observe that 1 by x plus 1 into x plus 2 can be factored out as, or can be made into two partial fractions like this: x plus 1 minus of 1 by x plus 2. Okay, because you see that x plus 2 minus x plus 1 in the numerator will give me 1 there, so it is this thing. So we are writing this 1 as x plus 2 minus of x plus 1 and now splitting the fraction into two fractions. Okay. Now, does this have an infinite expansion? So we split this into partial fractions this way: 1 by x plus 1 minus 1 by x plus 2. Actually, in this problem, if you need to have ascending powers of x in the expansion here, we will look at this as 1 plus x raised to the power minus 1, and minus, you can take out a 1 by 2 common, and I write this as 1 plus x by 2 raised to the power minus 1. What we do is, we take out a 2 common here, x by 2, and then make it 2 into x by 2 plus 1 here. So this 1 by 2 retains as it is, 1 plus x by 2 raised to the power minus 1. Now here we need to use an expansion formula, 1 plus x power minus 1. What is 1 plus x power minus 1 expansion? 1 minus x plus x square minus x cube, alternating sign pattern, plus x power 4, so on and so forth. It has an inherent infinite series expansion, and it would be convergent, or it will be a finite value provided mod x is less than 1. We are assuming here that mod x is less than 1, and this is a valid expansion there. So going by that assumption here, let's see what we have here. Now, what about 1 plus x by 2 raised to the power minus 1? That's going to be having 1 minus x by 2 plus x square by 4 minus x cube by 8, 2 cube there, and plus x power 4 by 16, so on and so forth. Now if you multiply this with half, let's multiply this with half. 1 plus x by 2 raised to the power minus 1. If you multiply with half, what do you have here? So you will get a half here, x by 2 into 2 here, 4 into 2, 8 into 2, 16 into 2. Every term gets divided by 2. Now what we were interested in is the coefficient of x power 4 in the difference of these two expansions. So we will we will collect only the x power 4 coefficient in the difference. What is the x power 4 term here? What is the coefficient of x power 4 here? 1. And what is the coefficient of x power 4 in this expansion? It is 1 by 32. So that is 1 minus 1 by 32 is the coefficient of x power 4 in the difference. So let's get back once more. This is 1 plus x raised to the power minus 1 has an expansion like this. And the right, in this part we have 1 plus x by 2 raised to the power minus 1. So we replaced x by 2 and we wrote the expansion and then we multiplied by 1 by 2. So we found that the x power 4 coefficient is having 1 by 32 here. And what is the coefficient of x power 4 here? 1 here. In the difference of these two expansions, we need the coefficient of x power 4. So what is that? 1 minus 1 by 32. So what's the answer? 31 by 32. Clearly? So clearly the option is 4. Answer is 4 there. Let's move on to the next question. Question number 21. 7 by 5 into 1 plus 1 by 10 square plus 1 into 3 by 1 into 2 into 1 by 10 power 4, 1 into 3 into 5 by 1 into 2 into 3 by 1 by 10 power into 1 by 10 power 6, so on up to infinity, is equal to first option root 2, second option 2, third option 21 by 3, fourth option under root of 2 by 3. Now let's have a look at this problem here. It has an infinite series expansion there. 7 by 5 into 1 plus 1 by 10 square, 1 into 3 by, we'll take it as 2 factorial there, into 1 by 10 power 4, 1 into 3 into 5 by 3 factorial into 1 by 10 power 6, so on and so forth. So we will write this as 10 square whole square, and we'll write this as 1 by 10 square whole cube, so on and so forth up to infinity. Now let's try to match it up with the expansion. This expansion, let's try to match it up with 1 plus x raised to the power n, when n is a 1 plus x raised to the power n, where n is a rational index, n rational number. This has an infinite expansion like this: 1 plus nx plus n into n minus 1 by 2 factorial into x square plus n into n minus 1 into n minus 2 by 3 factorial into x cube, so on and so forth. An infinite expansion provided mod x is less than 1. This 1 plus x power n has an expansion like this, provided mod x is less than 1. Now let us try to match up this expansion with that. Okay, what do you have here? This inside the bracket, the expansion which is inside the bracket, this one appears to be matching with this, and this nx should have been 1 by 10 square. So nx will take it as 1 by 10 square. What about the next term here? What do you have here? We have the 2 factorial and this 1 by 2 10 square whole square, that appears to be coinciding with 1 by 10 square whole square there. So let's see that. What we do is this, we'll write it in the form of nx, 1x will take it to this, 1x will take it inside of this bracket. So we'll have nx into nx minus x by 2 factorial can be matched with this term here. This term, what is that? 1 into 3 by 2 factorial into 1 by 10 square whole square. 1 by 10 square whole square. Okay, now what we'll do is this 2 factorial cancel that out, and now let's put the value of nx here nx in this. So, what do we get? 1 by 10 square. Instead of nx, I am writing 1 by 10 square, and instead of here 1 by 10 square minus x. This x we will have to find out. We will find out that x here, the 2 factorial got cancelled, and we have 1 into 3 into 1 by 10 square whole square. Now, this 1 factor of 1 by 10 square and this will cancel it out. So, what do we have here? We have here okay, 1 by 100 minus x is equal to 3 by 100. So, 3 by 100 there. So, what does that make it? X is equal to 1 by 100 minus 3 by 100. That makes it x is equal to minus 2 by 100, that is minus 1 by 50. X is equal to minus 1 by 50. But what did you know about, nx? Nx was 1 by 100. So, n into, what is n into, we have in place of x minus 1 by 50, that is equal to 1 by 100. Now, clearly this implies n is equal to minus 1 by 2, because minus 1 by 2 multiplied by minus 1 by 50 will give me 1 by 100. So, the n value is minus 1 by 2 and the x value, what did you get? Minus 1 by 50. So, let us take these two values and write the expansion. It is simply, this part is nothing but 1 plus x power n. So, where n is equal to minus half and x is equal to minus 1 by 50. So, let us write that now. Let us substitute the x value and n value here. Let us substitute the x value and n value here. So, what does this come out to be now? 1 plus x is minus 1 by 50. So, 1 minus 1 by 50 in raised to the power minus 1 by 2. So, that makes it 49 by 50 raised to the power minus 1 by 2. So, I can even write this as 50 by 49 raised to the power half. What is x power half? Nothing but the square root of x. So, 50 by 49 root 50 by root 49. Root 50 by root 49. What is this now? This is 5 root 2 by 7. So, this entire expression which is in this bracket is now becoming 5 root 2 by 7. 5 root 2 by 7. So, what is it now? We need to, I'll substitute this 5 root 2 by 7 here. So, we will have 7 by 5 into this entire thing in the bracket is 5 root 2 by 7. Therefore, what we have is by 7. The 7 and 7 cancels and this 5 cancels. So, what's the answer there? Answer is root 2. So, clearly the answer is root 2 and therefore, the option is clear, right option is answer 1 there. So, let us move to the next question. The coefficient of x power 53 in the expansion of 100 sigma m ranging from 0 to 100 cm x minus 3 raised to the power 100 minus m into 2 power m is 100c 53 minus 100c 43 minus 100c 53. Fourth option is 100c 50. Now, what are we given? The expansion is, the expansion that we are given is sigma m ranging from 0 to 100 cm into x minus 3 raised to the power 100 minus m into 2 raised to the power m. Now, if you observe carefully, this is in the form of NCR, sigma r ranging from 0 to n, some x plus x power n minus r into a power r. That is like a standard binomial expansion. So, what is it? We can club this into x minus 3 plus 2. We can write this as x minus 3 raised plus 2. raised to the power 100. This x minus 3 is the first term and 2 second term in the binomial. This comes out to be this. What is this now? X minus 1 raised to the power 100. Okay, but that we can write it in the form of 1 minus x power 100 as well. And clearly the coefficient of x power 53 in this expansion is 1 minus x power 100 expansion. What is the expansion of 1 minus x power 100? That is sigma r ranging from 0 to 100, 100 CR into minus 1 power r into minus 1 power r into x power r. In this expansion, we are interested in the coefficient of x power. This is 1 minus x power 100. So in this expansion, we are interested in the coefficient of x power 53. So r has to be 53. So if I put r is equal to 53 here, what do we get? The term that we get is 100C53 multiplied by minus 1 raised to the power 53. Minus 1 raised to an odd number is a minus 1. So that turns out to be minus 100C53. Now denoting it in a different way, we have a notation NCR. In some books they write it in the form of NCR, which is same as CNR. That is also another notation. So the options, you can use this notation or this notation here. So this becomes minus of C153, which is nothing but minus 100C53, and therefore clearly the right option is 3, answer 3. Right option is answer 3 there. Okay, let's move to the next question here. If Pn is the product of binomial coefficients in the expansion of 1 plus x power n, then Pn plus 1 by Pn is equal to n plus 1 raised to the power n by n factorial. Second option, n plus 1 by n factorial. Third option, n plus 1 raised to the power n by n. Fourth option, 0. Okay. What is the expansion of 1 plus x power n? C0 plus C1x, NC0 plus NC1x plus NC2x square, so on, NCn x power n. Now, what is Pn he has given? He has given that Pn is nothing but product of these binomial coefficients, NC0 into NC1 into NC2, so on, so forth, NCn. What is Pn plus 1? Wherever there is n, I need to replace it with n plus 1. So I'll have here n plus 1 into C0, n plus 1 C0, sorry. That is the expansion. In the expansion of 1 plus x power n plus 1, we need to look at the binomial coefficients and take the product of them. So Pn plus 1 will be n plus 1 C0 into n plus 1 C1 into n plus 1 C2, so on so forth. You will have n plus 1 Cn definitely, and in addition we will have one more binomial coefficient, that is n plus 1 Cn plus 1. Okay. Now what you are interested in is Pn plus 1 by Pn. Okay. This divided by this. What we do is we will separate out this term and write the quotient of this. That is n plus 1 C0, we will write it separately, and we will now shift the entire thing, n plus 1 C1 by NC0, n plus 1 C2 by NC1. We will keep clubbing like this, and this will be clubbed with this thing later, last. So we will have n plus 1 C1 by NC0 into n plus 1 C2 by NC1, so on so forth. Finally, n plus 1 C n plus 1 by NCn. Okay. Now we can put this entire thing, this product of n terms here, product of n quotients here, into, we have product of n plus 1 binomial into product here, the product here. Okay, the product of this n plus 1 terms, I will put it in a product symbol r ranging from 0 to n plus 1 CR plus 1 by NCR into n plus 1 C naught. This n plus 1 C naught is anyway 1, so you can actually forget about this. Now coming to this. Now here we need to make use of some result here. N plus 1 by CR plus 1 by NCR. What does that turn out to be? Now let us consider this n plus 1 CR plus 1 by NCR. What is this actually? Right, the numerator we write starting from n plus 1, r plus 1 consecutive numbers, n plus 1 into n, next n minus 1, so on and so forth. When you are writing 3 consecutive numbers, you are subtracting out from n plus 1 a 2. So when you are writing r plus 1 consecutive numbers, you will be subtracting out r, n plus 1 minus r, divided by r plus 1 multiplied with r plus 1 factorial. That is what you get in the numerator. In the denominator, we will have r consecutive numbers starting from n into n minus 1 into so on. When it is rth consecutive number, n minus of r minus 1 divided by r factorial. So in this, observe that this r plus 1 factorial, we can write it as r plus 1 into r factorial. So that r factorial cancels out. You will be left with an r plus 1 here. And what do you observe? This is nothing but n minus r plus 1, and this is also n minus r plus 1. This part, these terms, all these terms, they get cancelled. And what are you left with? N plus 1 and here by r plus 1. So that turns out to be n plus 1 divided by r plus 1. So this, observe that this product, in this product, each term will be in the form of n plus 1 by r plus 1. So we can now write this product this way. This product, the product r ranging from 0 to n plus 1 CR plus 1 by NCR will be product of n plus 1 by r plus 1, r ranging from 0 to n. What is this now? N plus 1 gets multiplied in each term, and how many times is product, how many terms are in this product? N plus 1. So we will have in the numerator n plus 1 raised to the power n plus 1. And in the denominator, we start, when you take r equal to 0, we get 1, and when you take r equal to 1, you get 2. So we will get 0, 1 into, in the 1 into 2 into 3, so on up to n into n plus 1. What is this? Clearly, this is, we can write this in the form of, the numerator has an n plus 1 power n plus 1. So we will take out one n plus 1 from here, and this n plus 1 and this n plus 1 will cancel it out. So what do we have finally? Finally, it turns out to be n plus 1 raised to the power n divided by, what's the denominator? The denominator comes out to be product, that is n consecutive numbers starting from 1 to n. So that is nothing but n factorial. So n plus 1 raised to the power n divided by n factorial. So what's the right option? The right option is answer 1 there. Let's move to the next question. If 1 plus x power n is equal to c naught plus c1x plus so on cn x power n, then the sum c naught plus c naught plus c1, the next bracket would be consisting of c naught plus c1 plus c2. The last bracket consists of c naught plus c1 plus so on cn minus 1 is equal to first option n into 2 power n, second option n into 2 power n minus 1, third option n into 2 power n plus 1, fourth option is 2 power n. Now let's look at this. 1 plus x power n has an expansion c naught plus c1x plus c2x square so on cn x power n. The CRs are the binomial coefficients here. We are to find out the value of c naught plus, let me write that bracket values in rows. C naught plus c1 next term, next c naught plus c1 plus c2, let me write like this. So this bracket terms like this, and here. So I am writing c naught, all the c naught terms in a particular, in a one column, c1 terms in a column, next c naught, c1, c2, the next term c3 there. Go on like this. What is the last bracket? That is the nth bracket there, okay, because the first is ending with 0, second is ending with 1, third with 2, last is ending up with cn minus 1, okay, cn minus 1, so on, c naught plus c1 plus c2 plus c3 up to cn minus 1. This is what you have there. Okay, now let us add the terms column wise. Let's add the term column wise. How many such rows have been filled up? This is row 1, row 2, and then row 3. When it is ending with 2, we are having row 3. When it is ending with n minus 1, it should be row n. Row n there. So n rows are there. Observe that the c naught is appearing in every row in the first column. So c naught, when you add it up, how many times it's getting added up? N times. So n into c naught. Okay. Now what about this here? We have c1 is getting added up n minus 1 times only. N minus 1 into c1. What about c2? That's getting added up n minus 2 times. N minus 2 into c2. Next, n minus 3 into c3. So on and so forth. Last term, that is cn minus 1, is getting added up only once. 1 into cn minus 1. Now observe that we have here all the binomial coefficients of the expansion 1 plus x power n except the last binomial coefficient, that is cn, that is missing. What I will do is, we will introduce that with a 0, 0 into cn. We will introduce that with a 0 into cn. 0 into anything is 0. So we can write that. I am introducing that here. So this is what I want, and let's call this as yes. Let us call the summation as yes. So what is my s? What is my s here? S is equal to n into c naught plus n minus 1 into c1, so on and so forth, 1 into cn minus 1 plus 0 into, we wrote cn. Now this same yes, we will reverse the sum, reversing the sum, I am writing. What will you get? 0 into cn, let me write here, 0 into cn, but when I am writing cn, I am going to write it as c naught, because cr is same as cn minus r. Use this. So reverse the sum and also use the fact that cr is equal to cn minus r. So cn is written as c naught. Next, that this term, we are moving from here, 1 into, how do I write, what should I write Cn minus 1 as? C1. So 1 into C1. Next, the previous term, I'll go on like this. What will come underneath this Cn minus 1? C1 term. What is it? What's the coefficient? N minus 1. N minus 1 into, I'll have C1 here. N minus 1 into C1. So instead of C, we'll have that C1, we're going to write it as Cn minus 1. And then here, what you had here was the C0 term, 0 into Cn term we have. We have n into C0, that is the last term, that comes here. And what? N into C0, C0 I'm going to replace it with Cn, so we have Cn there. I'm making use of the fact that NCR is same as NC, n minus r. And what am I doing? We're reversing the summation and writing it. So now what we do is we'll add up this s and s. This 2s, we'll consider 2s. What do we have? C0 taken common in the first column. We have n into n plus 0, n into C0. Next, what do we have here? C1 taken common in the next column. So n minus 1 plus 1. That makes it n again. So n is taken common. Plus C2. We would have got n minus 2 into C2 here and 2 into C2 here. That compensates and we get n into C2. So what we have finally, this 1 plus n minus 1, that makes it n into Cn minus 1. So that is, n has already been taken out, so we have Cn minus 1. And 0 plus n into Cn, so that is again n. So n Cn, and n has been taken common out, so we have. Now what is this turning out to be? Right hand side is sum of all the binomial coefficients in the expansion of 1 plus x power n. And what do we know that to be? Consider this expansion 1 plus x power n. We already have it. So put x equal to 1. Putting x equal to 1 here. What do we have? 2 power n is equal to C0 plus C1 plus so on Cn. The sum of the binomial coefficients we have here is 2 power n. So what you have here is 2s is equal to n into this 2 power n. What is this? 2 can be cancelled out and you are left with the 2 power n minus 1. Therefore s is equal to 2 power of n minus 1. That is what we wanted. We wanted the summation of those n bracket terms there, and we got that to be 2 power n into 2 power of n minus 1. Therefore clearly the answer is 2 there. Answer is 2. Second option is the answer. Let's move to the next question. 1 minus x square raised to the power 20 is equal to sigma AR x power r ranging from 0 to 40, then A1 plus 3 into A3 plus 5 into A5 so on up to 39 into A39 is equal to first option 40, second option minus 40, third option 80, fourth option minus 80. Let's have a look at this. 1 minus x square raised to the power 20. That's the left hand side. Observe that this is a quadratic raised to the power 20. That should be 40th degree polynomial, and that's what has been written. It is written in the summation AR x power r ranging from 0 to 40. That's clearly a 40th degree polynomial there. Now some relation between the coefficients has been asked here. Observe that we are interested in A1 plus 3 into A3 plus 5 into A5 plus 7 into A7 so on and so forth. 39 last odd coefficient, odd power term coefficient we are writing 39 into A39. So now observe that it appears that this r is getting multiplied with AR, but we have only odd terms here. when we have already observed in one of the problems that when you want this r out here, r into ar, we need to differentiate both sides. But then again we need to only look at odd suffix terms. So let us see how we manipulate here. Okay, let us differentiate first. Differentiating with respect to x, both sides. We have 20 into 1 minus x square raised to the power 19 into the derivative of this 1 minus x square. What is that? Minus 1 minus 2x. And what do you have on the right hand side? Sigma r into ar into x power r minus 1, r ranging from. Now when I put when we take r equal to 0, that is a constant term. What is the derivative of the constant term? 0. Therefore it starts from 1 to 40. It goes up to 40 there. So it will be 1 to 40 there. If I put x equal to 1 here, I put x equal to 1. Put x equal to 1. So what do we have? 20 into 1 minus 1, that makes it 0, a minus 1, minus of 1 square, that is 1, and then minus 1 raised to the power 19 there. Okay, I put x equal to 1, then we get this 1 minus 1, 0, 0 minus 1, minus 1 raised to the power 19 into, I will take out a minus common and I write, okay, minus common and 1 plus 2 into 1 there. Okay, that makes it 3, and minus 1 power 20, that makes it plus 1. So 20 into 3, that is what you get. So what we get here is, left hand side it comes out to be, okay, minus 1 plus 19 plus 1, that makes it plus 1 there, and we have 1 plus 2, that is 3 into 20, 60, and that is coming out to be sigma r into ar, r ranging from 1 to 40. Looking at it in the expanded manner, this is what you have, that is, we have a1 plus 2 into a2 plus 3 into a3 plus so on and so forth. 40 into a40 is coming out to be 60. That is 60. Right. But we are not interested in even suffix terms. So what shall we do? In this expansion again, we put x equal to minus 1 and then subtract one from the other, or add the two terms there. So what we do is, we put x equal to minus 1, put x equal to minus 1 here. If you put x equal to minus 1, what do you get? 20. 1 minus of minus 1, that makes it 2. 2 minus 1, that makes it 1 there. 1 power 19. And here we have minus 1 plus 2. Okay, that is 1 there, 20 there. And what do you have on the right hand side? Right hand side, we will get alternatingly a1 minus 2a2 plus 3a3, okay, minus 4a4, so on and so forth. Okay, and we'll have minus 40a40. So that even suffix terms will have a minus sign, odd suffix terms will have a plus sign only. This is a1 there. Now what do you have on the left hand side? It is just 20. All this is coming out to be 20. Now let us add these two, equation 1 and equation 2. Let us add these two equations. What do we get here? 60 plus 20, 80 is equal to 2 into a1. The odd even suffix terms will get cancelled. a1 plus 3 into a3 plus 5 into a5 plus so on 39 into a39. 39 into a39. So what is that coming out to be? So that is coming out to be, so this 2 cancels and we have a 40 here. Therefore 40 is equal to A1 plus 3 into A3 plus 5 into A5 so on, 39 into A39. So clearly the answer for this question is 40, and we have that in the option 4. Answer is in 1 there. So let's move to the next question. Let R be equal to 5 root 5 plus 11 raised to the power 2n plus 1, and f is R minus bracket of R, that's a fraction part of R, where bracket denotes the greatest integer less than or equal to R, and if f small f is equal to 5 root 5 minus 11 raised to the power 2n plus 1, then we have 2 lists and which we have to be matching. So list 1, bracket of R, in the option of list 1 we have bracket R, R into f, f minus capital F. Fourth option, is capital R minus f, small f, and in the list 2 we have 0, 4 power 2n plus 1. Third option, third odd integer, fourth even integer, and fifth 4 power 2n minus 1. The correct match of this list 1 with the list 2 is A, B, C, D. The first option is A should be matched to 2, B to be 3, C to be 1, and D to 5. Second option 1, 5, 2, 3. Third option 1, 3, 1, 2, 4. Fourth option 4, 2, 1, 4. So let's have a look at this question here. R is equal to an expansion 5 root 5 plus 11 raised to the power 2n plus 1. R is equal to 5 root 5 plus 11 raised to the power 2n plus 1. And now this R has been written as bracket of R. This may not be an integer. So it is some integer part, it has some integer part, that plus some fraction. That is capital F. That's what has been written there. Now you are also given f to be equal to 5 root 5 minus 11 raised to the power 2n plus 1. Now let's have a look at this first. Forget about this power for a moment, 2n plus 1. We have here 5 root 5 minus 11 in the base. What is the approximate value of root 5? 2.2 something. Okay, 5 root 5 minus 11 will be a fractional quantity that when raised to higher powers you further get a positive fraction. So what is it you get? We get this to be clearly f lies between, small f lies between, belongs to the interval, open interval 0 to 1. This is not an integer, so the fraction, it is simply, it has to lie between 0 and 1. Moreover, capital F also, observe that capital F is also the fraction part of it, because this is the integer part of this R here. So capital F has to be also lying between 0 to 1. This also belongs to 0, 1. Now what you do is, you consider f minus r. Consider f minus r. Consider f minus r. Okay, what is that? 5 root 5 minus 11 raised to the power 2n plus 1 minus of 5 root 5 plus 11 raised to the power 2n plus 1. Let's consider this. But what was r there? Bracket r plus f. So let me write the left hand side comes out to be 5 minus of bracket r minus f, capital F, is equal to 5 root 5 minus 11 raised to the power 2n plus 1, 5 root 5 plus 11 raised to the power 2n plus 1. Observe that here alternatingly there will be a sign pattern change because of this presence of this minus 11 term here, and this comes out to be, let's put it in the expanded form, 2n plus 1 c naught 5 root 5 raised to the power 2n plus 1. Okay, next plus and a minus of 5 root 2n plus 1 c1 into 5 root 5 raised to the power 2n into 11 and so on. I am writing the first expansion here, plus 2n plus 1 c2 into 5 root 5 raised to the power 2n minus 1 into minus 11 square. So that makes it plus 11 square. So I'll just 11 square will write it, so on and so forth. That's the first expansion. What about the second expansion? Second expansion will have all the terms with the plus sign there. So minus of 2n plus 1 c naught. So all these terms, they will appear with a plus sign there. So what we have is 2n plus 1 c naught into 5 root 5 raised to the power 2n plus 1 plus 2n plus 1 c1 into 5 root 5 raised to the power 2n into 11. Next plus 2n plus 1 c2 into 5 root 5 raised to the power 2n minus 1 into 11 square. We get like this, all positive terms. Now observe that because you are subtracting, even suffix terms will get cancelled. They get cancelled. So even position terms get cancelled, even suffix terms get cancelled. So even position terms remain, but they will appear, there is minus sign common here, minus sign common. So what do we have? And they will appear double, two times there. So we have right hand side, we will take it to be, right hand side comes out to be RHS. Let's only write the right hand side here. RHS comes out to be minus 2 times of, so odd suffixed terms here, 2n plus 1 c1, 5 root 5 raised to the power 2n. What is that? A root raised to even power there. So what is that giving me? Some integer. 5 root 5 raised to the power 2n, that's going to be an integer. Integer into 11. That's going to be again an integer. Next, 5 root 5. So this term is also getting cancelled there with this here. Okay. So we have this 2 term cancels. Now 5 root 5 raised to the power 2n, and then again we'll have, what is the term that remains? 2n plus 1 c3 into, again you will have 5 root 5 raised to the power 2n minus 2, that's going to be an even number. So that is again an integer into 11 cube maybe. So it's 11 cube and so on and so forth. So what do you observe this to be? It is right hand side is going to be an even integer. It is 2 times an integer. So it's an even integer. So what you observe is, what we have observed here is f minus bracket r minus, this bracket r we can write it f minus capital F minus bracket r is an even integer. This is what you have observed, is an even integer. Okay, so what is it you can say now? F minus capital F is, this bracket r can be taken that side, it is again an integer. Because bracket r is always by definition as an integer, integer plus an integer, even integer or whatever, so it's going to be an integer. But let's have an observation. What do you know about small f and capital F? They both lie between 0 and 1. f and capital F, we know that they lie between 0 and 1. So what can you say about f minus capital F? It has to lie, f minus capital F should lie between minus 1 to 1. F minus F should lie between minus 1 to 1. Okay, but f minus F is an integer. What's the only integer between minus 1 to 1? It has to be 0. So f minus F has to be 0. F minus F is 0 there. So how did we conclude this? F minus F, we have found that it has to be an integer. How is that an integer? Bracket R is an integer. We had on the right hand side an integer. So integer plus integer, that's an integer. So f minus capital F is an integer. So now we have here, but f and small f and capital F were both lying between 0 and 1. Therefore the difference has to be between minus 1 and 1. Okay, therefore f minus capital F has to be 0 only, because the only integer that strictly lies between minus 1 and 1 is 0. So this is, therefore f is equal to capital F. F is equal to capital F. This is one observation that you have made. So what is the observation we have made? F is same as capital F. So when you have f to be capital F, what do you have? F minus F is 0. So bracket of minus of bracket of R is an even integer. So clearly this being 0 here, this is 0. Let's put that there. We have minus of bracket R to be an even integer, which in turn implies that, therefore we can write, therefore this implies bracket of R is an even integer. So clearly A has to be matched with 4. A has to be matched with 4. Okay, in the list 1, A has to be list 2. List 2 says fourth option is even integer. So A has to be, bracket R has to be definitely an even integer. Now we'll have to go by next. What is it that's being asked? He's asking about R into capital F. But what is R? What is R? 5 root 5 plus 11 raised to the power 2n plus 1. What is capital F? Same as 5 root 5 minus 11 raised to the power 2n plus 1. So that makes it R into small f I can write. But what is R into small f? That makes it, it's in the form of x plus y into x minus y, both raised to the power 2n plus 1. So that makes it 5 root 5 square minus 11 square, a plus b into a minus b, a square minus b square, a whole thing raised to the power 2n plus 1. So what is this 5 root 5 square is? 5 square, 25 into 5, that is 125. 125 minus 11 square, 125 minus 121, that is 4. 4 raised to the power 2n plus 1. So clearly for B has to be matched with 2. B has to be matched with 2. Actually right now we can as well say it has to be the answer 4, because 2 of the options are already matching, then that's the only possibility, 4, 2. And it's simple to check that f minus f is anyway 0. So option 1 is clear there. And R minus f, what is R minus f? R minus f is again going to be an even integer. R minus f is an even integer. So that's it. What is R minus? Because you see here capital F is nothing but small f. So transpose this small f that side. Therefore what do you get? R minus small f. What is R minus small f? That comes out to be bracket R. And what is bracket R? We have already seen it is an even integer. Therefore we have this 4, 2, 1, 4. A is mapped to 4. So A has to be 4 and B has to be 2, C has to be 1 and D has to be 4 again. So this is the right matching, and that matching is appearing in the option 4. Option is 4. Answer is 4. Fourth option is the answer. Let's move on to the next question. If Sn is equal to sigma r ranging from 0 to n 1 by NCR, and Tn is equal to sigma r ranging from 0 to n r upon NCR, then Tn by Sn is equal to n by 2, 2n minus 1 by 2, n minus 1, and fourth option is n by 2 minus 1. Let's have a look at this. Sn is equal to sigma r ranging from 0 to n 1 by NCR. Tn is equal to sigma r by NCR, r ranging from 0 to n. Now, let's make an observation about the sum Tn. What is this? This is 0 by NC naught, 1 by NC1, so on and so forth, n by NCn. I can reverse the summation here. If I write it in the reversed order, this I can look at what is the previous term previous to this. The term previous to it is n minus 1 by NCn minus 1. Okay, the term previous to the last term there. Now observe that we can write the summation in the reversed order. So what do we get? We have n minus r by NC n minus r sigma r ranging from 0 to n. So when I put r equal to 0, I will get n minus 0 by NC n minus 0. And when I put r equal to 1, I will get n minus 1 by NC n minus 1. So on, coming back. When I put r equal to n, I will get 0 by NC n minus n, that is NC naught. But have a look at this denominator here. NC n minus r is nothing but NCR. So we can replace this summation in the denominator of the summation here as NCRs, r ranging from 0 to n. So this Tn has been alternatively written in this way. What is that? R by NCR is one thing that is already given, and we could, when you revise the summation, it looks like n minus r by NC n minus r, but NC n minus r we know is same as NCR, so we can write this as n minus r by NCR. So now let's add up these two summations, Tn plus Tn. So 2Tn is equal to, since the denominators are same in both these terms here, so we'll have r plus n minus r in the numerator divided by NCR, sigma r ranging from 0 to n. And what is this now? This turns out to be, this r and r cancels, and we have here n into sigma 1 by NCR. Now this n has been pulled out because the summation is ranging only, what is the indexing variable? R. What is changing in the summation? It's only r that's changing, n is fixed in it, and that gets multiplied with every term. So n into 1 by NCR, sigma r ranging from 0 to n there. Go back to see what is this 1 by NCR summation r ranging from 0 to n, that was given to be Sn. So we have 2 into Tn is therefore equal to n into Sn. This, the term in the bracket is equal to your Sn. So what we have is 2 into Tn is equal to n into Sn. What we wanted was Tn by Sn. What is Tn by Sn now? Clearly it is n by 2, and the option is 1. Answer 1. Option is 1 there.